Today I'll talk about average molecular weight of a gas mixture, Raoult's law and Henry's law. Average molecular weight of a gas mixture. The average molecular weight of a gas mixture is essential for calculating the weight of a mixture. It is computed by assuming the quantity of a gas mixture as 1 mole. Now, what is average molecular weight? How do you calculate that? Now consider a gas mixture with component A, B, C. Let Ma, Mb and Mc be the molecular weight and Xa, Xb and Xc be the mole fraction of this component. The average molecular weight M average is given by M average is equal to molecular weight of A into mole fraction of A, molecular weight of B into mole fraction of B, molecular weight of C and mole fraction of C. So that is summation of Mi Xi. So I is equal to 1 to n. So if n components are there, so Mi Xi summation of I is equal to 1 to n Mi Xi. Now here is the example of average molecular weight calculation. Now a gas mixture contains 50% of oxygen and 30% nitrogen and 20% carbon dioxide. Now calculate the average molecular weight. Now we know that mole percent is equal to volume percent is equal to pressure percent. So now here that first molecular weight of oxygen, so that is 32 gram by mole, molecular weight of nitrogen 28 gram per mole, molecular weight of carbon dioxide 44 gram per mole. Now here that mole fraction of oxygen, so that is 50%, that is nothing but 0.5. Even if I take the mole basis or volume basis, so oxygen mole fraction is 0.5, nitrogen mole fraction is 0.3 and carbon dioxide mole fraction is 0.2. Now we know that M average is equal to summation of or molecular weight of oxygen into mole fraction plus molecular weight of nitrogen into X mole fraction of nitrogen plus molecular weight of carbon dioxide and mole fraction of carbon dioxide. So now here 32 molecular weight mole fraction plus molecular weight of nitrogen into mole fraction of nitrogen, molecular weight of carbon dioxide into mole fraction of carbon dioxide. So now here from if we multiply 32 into 0.5, that is 60, then 28 into 0.3, that is 8.4, 44 into 0.2, that is 8.8. so total average molecular, if we add all this, so that will be 33.2 gram per mole. So average molecular weight is 33.2 gram per mole. Now density of a gas mixture. So density of a gas mixture at a given temperature and pressure is calculated using ideal gas law. Knowing the average molecular weight of the gas mixture is essential. Now we know that PV is equal to nRT. Now P is nothing but N by V RT. So now N is nothing but M by M, that is mass by molecular weight. So that is nothing but N. Now if we plug that, P is equal to M by V by molecular weight RT. So now here, so this is nothing but rho. So now it will be so here M by V is rho. So rho is nothing but what? So we can multiply rho is equal to P M molecular weight divided by RT. So now here that is we can get that. So rho is equal to P average molecular weight R and T. So now the ideal gas equation for the gas mixture is PV is equal to nRT. Now from here we can calculate the density. So density is nothing but P into average molecular weight by RT. So here P is the pressure, Mg is the average molecular weight, R is the universal gas constant and T is the temperature. Now here I am taking one example and then I'll show you how to calculate density. So density of a gas mixture example. Calculate the density of a gas mixture at 100 kilopascal and 300 Kelvin with an average molecular weight 33.2 gram per mole. So now P is given 100 kilopascal, T is given 300 Kelvin, average molecular weight is given 33.2 gram per mole. So that is 0.0332 kg per mole. Now kg per mole we can do that. So now here R is 8.314 meter cube kilopascal kilomole Kelvin. So now here if we plug all this value, so that is 100 kilopascal, then this is 0.0332 as a that average molecular weight kg per mole, and then 8.314, so that is universal gas constant, and 300 is the temperature. Now here from that if we calculate, so that will be 0.00133 kg per meter cube. So that is the density. So then density is 0.00133 kg per meter cube. So now Raoult's law. Raoult's law relates the partial pressure of a component in a vapor phase to its mole fraction in the liquid phase and its vapor at its pure component of vapor pressure. So here for a component A, so this is the partial pressure, this is vapor pressure of the pure component into the mole fraction in the liquid phase. So here PA is the partial pressure, PA 0A, that P 0A is the vapor pressure of the pure component, and X is the mole fraction in the liquid phase. Okay, so now if we have that solution, so that A and B is the solution. So partial pressure of A is nothing but vapor pressure of A and that liquid mole fraction, so that is into Xi. Now here is one example. Calculate the partial pressure of acetone in solution where its mole fraction is 0.4 and vapor pressure is 200 mg. So vapor pressure is given, mole fraction is given, so PA we can easily calculate 200 into 0.4, so that is 80 mmHg. Next is Henry's law. Henry's law states that the concentration of gas dissolved in a liquid is directly proportional to the partial pressure of the gas above the liquid. So here that Xa, mole fraction in the liquid, so that is Pa by Ha. Ha is actually Henry's law's constant. So Xa is the mole fraction in the liquid phase, Pa is the partial pressure, and Ha is the Henry's law's constant. So we can write Pa is nothing but Xa into Henry constant H, or Xa is nothing but Pa by H. That's it. Thank you.